Download this code from codegive.com, link in the description below. OK, let's dive deep into debugging with code blocks, covering error checking, code examples, and practical debugging techniques. This will be a comprehensive guide. Introduction to debugging and code blocks. Debugging is the process of finding and fixing errors, bugs, in your code. These errors can prevent your program from running, produce incorrect results, or behave unexpectedly. Debugging is a critical skill for any programmer. Code Blocks is a popular, free, and open-source integrated development environment, IDE, that provides a convenient environment for writing, compiling, and debugging code. It supports various compilers, GCC, Visual C++, etc., and is available for Windows, Mac OS, and Linux. 2. Types of errors. Before we start debugging, it's helpful to understand the different types of errors that can occur. 1. Syntax errors *. These are violations of the programming language's grammar. The compiler detects them during compilation and prevents the program from running. Examples: missing semicolons, mismatched parentheses or braces, incorrect keywords. 2. Semantic errors *. These errors occur when the code is syntactically correct but doesn't do what the programmer intended. The compiler won't detect these, but the program's output will be wrong. Examples: incorrect logical operators, and end verses. Off by one errors in loops. Using the wrong variable name. 3. Runtime errors *. These errors occur while the program is running. They can cause the program to crash or behave unpredictably. Examples: division by zero. Accessing memory that doesn't belong to your program, example accessing an array out of bounds. Null pointer dereference. Stack overflow, usually caused by infinite recursion. 4. Logical errors *. These are subtle errors in the program's logic that lead to incorrect results. They are the hardest to find because the program might run without crashing, but it won't produce the correct output. Examples: incorrect formula, wrong algorithm. 3. Setting up code blocks for debugging. 1. Installation *. If you haven't already, download and install code blocks from http://www.codeblocks.org/ http://www.codeblocks.org. Be sure to download the version with a compiler, example Mingo for Windows. 2. Compiler configuration * Code blocks typically detects your compiler automatically. If it doesn't, go to Settings - Compiler. Select the compiler you want to use, example GNU GCC compiler. In the Toolchain Executables tab, verify that the paths to the compiler executables, example gcc.exe, g++.exe, gdb.exe, are correct. If not, adjust them accordingly. Usually, the installer does this correctly. 3. Compiler flags, important for debugging. Go to Settings - Compiler. Select the compiler you're using. Click on the Compiler Settings tab. Click on the Compiler Flags subtab. Enable these flags for debugging G, this flag is crucial. It tells the compiler to include debugging information in the compiled executable. Without this, you won't be able to use the debugger effectively. Wall, this enables almost all compiler warnings. Warnings can help you catch potential problems in your code before they become errors. Extra enables additional compiler warnings. Asterisk pedantic, enforces stricter adherence to the language standard. Asterisk for release builds, optimized, without debugging information. When you're ready to release your program, you can use the following flags to optimize the code for speed and size. Be careful using these during development as they can mask some bugs. Remove G and add asterisk O2 or O3, optimization levels. Asterisk S, strip debugging information from the executable. 4. Create a debug configuration. Asterisk code blocks provides different build configurations. Debug and release are common. When creating a new project, a debug and release configuration are created automatically. If you want to add a build configuration, asterisk build-manage targets. Asterisk click add, give a meaningful name and copy settings from debug configuration. 4. A simple example program with errors. Let's create a simple C++ program with some intentional errors to demonstrate debugging. Save this code as debugging_example.cpp. Debugging with code blocks, a step-by-step guide. 1. Compile the program asterisk. Asterisk open the debugging_example.cpp file in code blocks. Asterisk go to build-build, or press Ctrl+Shift+B. Asterisk look at the build log at the bottom of the code blocks window. If you have syntax errors, the compiler will report them here. Double-clicking on an error message will usually take you directly to the line of code where the error occurred. 2. Correct syntax errors asterisk. Asterisk in our example, uncomment the commented outline with missing semicolon. Asterisk build the project again. Keep fixing syntax errors until the build is successful, no errors are reported. 3. Set breakpoints asterisk. Asterisk a breakpoint is a marker that tells the debugger to pause execution at a specific line of code. This allows you to examine the values of variables and step through the code line by line. Asterisk to set a breakpoint, click in the gray margin to the left of the line number where you want to pause. A red dot, or similar, will appear, indicating the breakpoint. Asterisk set breakpoints on the lines where you want to inspect the values of age, name, or other variables. A good starting point is the if statement. Another good breakpoint is right before accessing the array out of bounds to examine the array before the error. 4. Start the debugger asterisk. Asterisk go to debug-start/continue, or press F8. Code blocks will compile and run the program, pausing at the first breakpoint you set. If you did not create any breakpoints, then the code will execute normally. 5. Debugger interface asterisk the code blocks debugger interface will become active. Here are the key elements. Asterisk code editor window asterisk the current line of execution is highlighted. Asterisk watches window asterisk, view-debug windows-watches. Here, you can add variables to watch. The debugger will display their current values. This is essential for understanding what's happening in your code. Asterisk call stack window asterisk, view-debug windows-call stack. This shows the sequence of function calls that led to the current point in the program. Useful for debugging recursive functions or when you're in a deeply nested function call. Asterisk threads window asterisk, view-debug windows-threads. Useful for debugging multi-threaded applications. Asterisk locals window asterisk, view-debug windows-locals. Displays the values of local variables in the current scope. Asterisk registers window asterisk, view-debug windows-registers. Displays the CPU registers. Generally not needed for beginner debugging. 6. Stepping through the code asterisk use the following debugger commands. Asterisk step into, F7 executes the next line of code. If the line is a function call, it steps into the function. Asterisk step over, F8 executes the next line of code. If the line is a function call, it executes the entire function and returns to the calling line. Asterisk step out, Ctrl plus Shift plus F7 executes the remaining code in the current function and returns to the calling function. Asterisk continue, F8 resumes execution until the next breakpoint is encountered or the program finishes. 7. Inspecting variables asterisk. Asterisk in the watches window, type the name of a variable you want to observe, example age, name. Press enter. The debugger will display the variable's current value. Asterisk as you step through the code, the values in the watches window will update, allowing you to track how the variables change. 8. Identifying the semantic error asterisk. Asterisk step into the if, age equals 25, statement. Asterisk observe the value of age in the watches window. You'll see that the assignment age equals 25 has changed the value of age to 25. The if condition is always true because it's evaluating the result of the assignment, which is 25, a non-zero value, which is considered true in C++. Asterisk fix asterisk change the if statement to if, age equals 25, to perform an equality check. 9. Dealing with runtime errors asterisk. Asterisk now, let's focus on the array out of bounds error. Set a breakpoint right before the line std could value at index 5, arr5 std and l. Asterisk run the debugger. When it hits the breakpoint, examine the arr variable in the watches window. You'll see that the array has 5 elements, indices 0 to 4. Asterisk the line arr5 attempts to access the element at index 5, which is beyond the valid range of the array. This causes a runtime error, likely a crash or unpredictable behavior. Asterisk fix asterisk to fix this, make sure you only access valid array indices, 0 to size, 1. In this case, change arr5 to a valid index like arr4. Or, check if the index is valid before you access the element. 10. Conditional breakpoints asterisk sometimes, you only want a breakpoint to trigger under certain conditions. Asterisk right-click on the breakpoint. Asterisk choose properties. Asterisk in the condition field, specify the condition. For example, age 40 would only pause execution at that breakpoint if the age variable is greater than 40. 11. Data breakpoints asterisk stop when a value of a variable changes. Asterisk debug add watch. Asterisk click advanced tab. Asterisk trigger breakpoint if the value has changed. 6. Advanced debugging techniques. 1. Memory debugging asterisk. Asterisk tools like Valgrind, available on Linux and Mac OS, can help you find memory leaks, invalid memory accesses, and other memory-related problems. Asterisk code blocks doesn't directly integrate Valgrind, but you can run your program under Valgrind from the command line. 2. Logging asterisk. Asterisk sometimes, the debugger is not enough, especially when debugging complex programs or multi-threaded applications. Asterisk you can add logging statements, using stdcode, fprintf, or a logging library, to output information about the program's state at various points. This can help you track down the source of errors. 3. Assertions asterisk. Asterisk assertions are conditions that you expect to be true at a certain point in your code. Asterisk the assert macro in C++ allows you to check these conditions. If an assertion fails, the condition is false, the program will terminate with an error message. Asterisk example, assert, age equals 0, this checks that the age is not negative. 4. Debugging multi-threaded applications asterisk. Asterisk debugging multi-threaded programs can be challenging due to race conditions and other concurrency issues. Asterisk use the threads window in code blocks to switch between threads and examine their states. Asterisk consider using thread synchronization primitives, mutexes, semaphores, etc., to avoid data races. 5 core dumps, post-mortem debugging. Asterisk when a program crashes unexpectedly, it can generate a core dump file, which is a snapshot of the program's memory at the time of the crash. Asterisk you can load a core dump into code blocks to examine the program's state and identify the cause of the crash. This is system dependent and may require configuration. 7. Best practices for debugging. 1. Write clean code. Asterisk well structured, readable code is easier to debug. 2. Test early and often. Asterisk don't wait until the end of development to start testing. Test small pieces of code as you write them. 3. Use version control, git commit your code frequently. This allows you to easily revert to a previous version if you introduce a bug. 4. Reproduce the error. Asterisk make sure you can consistently reproduce the error before you start debugging. 5. Isolate the problem. Asterisk try to narrow down the location of the error as much as possible. Comment out sections of code to see if the error still occurs. 6. Take breaks. Asterisk if you're stuck on a difficult bug, take a break and come back to it later with fresh eyes. Sometimes, a fresh perspective is all you need. 7. Explain the problem to someone else. Rubber duck debugging. Even if the person you're talking to doesn't know anything about programming, the act of explaining the problem can often help you identify the solution. 8. Use online resources. Asterisk search for error messages and solutions on Stack Overflow and other programming forums. 8. Common debugging scenarios and solutions. 1. Segmentation fault. Seg fault. This is a common runtime error that usually occurs when you try to access memory that your program is not allowed to access, example accessing an array out of bounds, dereferencing a null pointer. Asterisk solution. Asterisk use the debugger to examine the values of pointers and array indices before the seg fault occurs. Make sure you're not writing to memory that you don't own. 2. Memory leaks. Asterisk these occur when you allocate memory using new, in C++, or malloc, in C, but fail to delete or free it when you're finished with it. Over time, this can cause your program to consume more and more memory, leading to a crash. Asterisk solution. Asterisk use valgrind or similar tools to detect memory leaks. Make sure you delete or free all memory that you allocate. Consider using smart pointers, example std unique _ptr, std shared _ptr, in C++ to automatically manage memory. 3. Infinite loops. Asterisk these occur when a loop's condition is never false, causing the loop to run forever. Asterisk solution. Asterisk set breakpoints inside the loop and examine the values of the variables used in the loop's condition. Make sure the condition will eventually become false. 4. Off by one errors. Asterisk these are common errors in loops and array accesses where you're either one iteration too short or one iteration too long. Asterisk solution. Asterisk pay close attention to the loop's starting and ending conditions. Use the debugger to check the values of loop counters and array indices. 9. Conclusion. Debugging is a fundamental part of programming. By mastering the techniques outlined in this guide, you'll be well equipped to find and fix errors in your code blocks projects. Remember to use the compiler warnings, the debugger, logging, and other tools to help you identify and resolve problems. Practice makes perfect. Good luck.